particle P moves in a straight line so that its displacement SCM from O is given by S equals to 28 plus 4t minus 5t square minus t cube cm. Another particle, okay, Q moves in a same straight line as P and starts from O at the same time as P. The initial velocity of Q is 2 centimeter per second and its acceleration is a centimeter per second square, and a is given by a equals to 2 minus 6t. Find t when P and Q collide and determine whether P and Q are traveling in the same direction or opposite direction at an instant of collision. Okay, quite a lot of information, and I think quite a substantial question as well. Okay, there'll be a lot of information or a lot of working involved, I think. Okay, let's start. Okay, every time when you get a question, please mark it or underline all the information that they have given. Okay, over here, that's the displacement, and also P moves in a straight line so that its displacement S from O is given that, and another particle Q moves in a straight line as P starts from O as well, okay, and at the same time as P. Okay, so the initial velocity of Q is 2 centimeter per second, and the acceleration is given by A, and A is given by the equation 2 minus 6t. P and Q collide and determine whether P and Q are traveling in the same direction or opposite direction. Okay, good question. Okay, let's start with now. So with this information, let's list down. S equals to 28 plus 4t minus 5t square minus t cube, and then A is given as 2 minus 6t. Okay, so since the initial velocity is 2 centimeter per second, but we don't have v, okay, what I can do is I can integrate. Okay, yeah, I can integrate. Oh, it's another particle Q moves on a straight line. P starts at Q. Okay, the initial velocity of Q is 2 cm and its acceleration is given. Okay, so for Q, this is for Q. Okay, acceleration for Q. So what I'm going to do, I'm going to integrate. Okay, I'm going to integrate 2 minus 6t to find the velocity of Q. So what I'll have here is 2t minus 6t square over 2 plus c. Okay, so that is our velocity. But before that, let's see what are the information that we have. It says 2 cm, okay, starts from O at the same time as P, but the initial velocity is already 2. So at O, t equals to 0, but velocity is already 2 cm per second. So 2 equals to 2 to the power of 0 minus 6 to the power of 0 square over 2 plus c. Okay, so from here we know 2 equals to that 0, so that's 0, so c equals to 2. So the velocity equation is v equals to 2t minus 3t square plus 2. Okay, so this is for Q. Okay, that's for Q, velocity of Q. So the information given here, you have P and Q, so don't get confused. So read it and then to understand. Okay, so next. Okay, I have that. Find t when P and Q collide and determine whether P and Q are traveling in the same or opposite direction. Okay, since they are talking about direction, okay, so certainly I need to have S. Okay, but this S is for P. What about the S for Q? So S for Q will be integrating V, which is 2t minus 3t squared plus 2. So what I have here is 2t squared over 2 minus 3t cubed over 3 plus 2t, okay, 2t, and then plus c. Okay, so from here s equals to t squared minus t cubed plus 2t plus c. Okay, and if you read the question, it says s, it starts at o. So at o, s equals to 0 and t equals to 0. Okay, every time when the question says at o, okay, most likely it has to be 0 unless other information is given. So read the question. Okay, in this question it says starts at o at the same time as p, so it's starting at the same point. So at o, t equals 0, s equals to 0. So from there I can get the equation for s equals to t square minus t cube plus 2t. Okay, so at the point of collision, okay, let's look at it. At the point P and Q collide and determine whether P and Q are traveling in the same or opposite direction. Okay, if P and Q are colliding, both particles would have traveled the same distance from O, isn't it? Okay, same distance from O. They would have traveled the same distance. Although they have different velocity, that doesn't matter, but the distance has to be same, okay, from O. So since that's the case, what I can do, I can equate s cubed with sp. Okay, I can equate s cubed with sp. So what is sp? 28 plus 4t minus 5t squared minus t cubed. And this is equal to sq, which is, where's sq? T cubed minus, sorry, t square minus t cubed and plus 2t. Okay, so let's solve this. So what I have, so negative 5t square minus t square minus t cubed plus t cubed and then plus 4t minus 2t plus 28 equals to 0. So it should be negative 6t square. So that's gone. Minus plus and minus, so that's 2t plus 28 equals 0. So if I solve all that and get rid of negative, so it should be 3t square minus becomes, so that should be plus, no, divide by minus 2, yeah, plus t minus 28 equals 0. Is that right? Sorry, that should be, oh, plus, yeah, okay, so it should be plus. Okay, so it should be plus 2t plus 28 equals 0. So that's negative, so negative t minus 28 equals 0. Okay, now put that into two brackets. Okay, I did this earlier, so it is 3t minus 7 and then t plus 2. So from here we know t equals to 7 over 3 and t equals to negative 2. So since it's negative 2, I can discard this. Okay, okay, what's left here is only positive value. Okay, so the positive value t equals to 7 over 3. If t equals to 7 over 3, what is the collide difference? Okay, so let's find out. Okay, at t equals to 7 over 3. The velocity is traveling at the opposite. Okay, let's find out the velocity. So velocity equals to 4. Where's that? Okay, yeah. So it's here. So it should be 4. Okay, differentiating. V is differentiating s over dt, and if I differentiate s for p, I'll have 4 minus 10t minus 3t squared. Okay, because I want to find what is the velocity. Okay, from there we know whether it's going backward or forward. Okay, what direction. So now I can take t equals to 7 over 3 sub inside, so it should be 4 minus 10 times by 7 over 3 minus 3, 7 over 3 square, and the answer that I had earlier was 4 minus blah blah blah. It's actually a negative value. Okay, it's a negative value. Yeah, I've got a negative value. I didn't proceed further. Why? Because it's negative, indicating negative. And for velocity, we know it's a vector quantity. So if it's negative, I know which direction that's going. Okay, so if this is O, if I take this way is positive, then this way should be negative. Okay, now this is for velocity of P. So what about velocity of Q? To find velocity of Q, do we have the equation for Q? Hang on, yes, 2t minus 3t squared. Okay, so 2t, what's that, 2t minus 3t squared plus 2. Okay, so we have that. So from there we sub t equals to 7 over 3 again. So 2 times by 7 over 3 minus 3, 7 over 3 square plus 2. Again, this is another negative value. Okay, so this is another negative value. So since I've got both negative value, that indicates that what it does, that indicates you're getting velocity, two velocities are negative. So at the point uh, at the point of collision, P and Q were traveling in the same direction. Okay, it doesn't matter which direction they go, but they were traveling in the same direction. Whether it's forward or backward doesn't matter. Negative just indicates that they are on the same direction. If one was positive and the other one was negative, then we know that one was moving forward, the other one is going backward, or opposite to each other. But in this case, both velocity are giving us a negative value, so that indicates they were traveling in the same direction. Okay, so quite a lot of information, so you got to do one by one. Okay, otherwise you will get stuck. But you can still do it. Okay.